Good day sa inyo tanan. So since our class has been suspended due to COVID-19, so ato ang i-continue ang atong discussion. So let's not stop learning. So previously we discussed about double integration method, which is one way of computing or determining the deflection at any point in the beam. But karon na ako ipakita sa inyo na new method. This is known as deflection method by moment area, okay, or otherwise known as moment area method. Okay, so first let's define what is moment area method. So the moment area method is useful for determining the slope or deflection of a beam at a specified location. So it is a semi-graphical method. When we say semi-graphical method, so we will be more on mag-drawing taog, or we will be more on graphing, or magamit taog graphical method to determine the slope, to determine the deflection. So mag-graph ta, in which the integration of the bending moment is carried out indirectly using the geometric properties of the area under the bending moment diagram. So basically here, ang ato ang slope or the bending moment is carried out indirectly using the geometric properties of the area under the bending moment diagram. So here, kwaon na to ang area sa bending moment. So, di ba ato ang from our previous discussion, ang ato ang moment is the changed in the shear, tama? But here man ang ato ang shear is the change in the area of our load. But in this case, ang ato ang himuon, ang slope na po, para makuha na to ang slope, it is just the area of the slope of the beam is just the area of our bending moment. Okay? So as in the method of double integration, we assume that the deformation is within the elastic range. So when we say elastic range, what do you mean by that? So within the proportional limit, no? Kata if this our stress strain, so kung ano siya atong strain, this is our stress, so within the proportional limit or within the linear limit. Okay, so therefore pag kwaon na to ang load, our beam should come back to its original position. Di wala tay mahitabo nga permanent deformation. Okay, so then we have just small slope and small displacement. So gamay lang dapat itong makompute ka slope, and also our displacement is very small, no? Dili kay siya dako ang atong displacement, kay pag dako ang atong displacement, that would cause failure sa to ang beam. Okay, so we have now, so for the computation of the slope, so we have the relationship of our slope and our moment. So our slope, no, it is just the area of moment diagram from A to B. So our slope of how are you going to read this? The slope of B relative to A. Okay, that's how you're going to read that. The slope of point B relative to A is just equal to the area of moment diagram from A to B. Okay, so what is slope of B relative to A? So if the slope of A, ang slope ni A, it is just the slope of the line tangent. This one here. Then, if we are going to compute the slope of B relative to A, it is just the angle between the two tangent. Okay, tangent kang B. So that is the slope of B relative to A. Okay, the slope of B from tangent A. Okay, so ang atong sign convention dali is we have positive change of slope. Positive ang atong change of slope. If ang ato ang direction is counterclockwise from the left tangent. So in this case, our left tangent here is aning line A. Mo ni ato ang left tangent ni A. So therefore, Si B, if you want to determine the slope of B from A, so kani, so unsay direction ani niya? Direction is padulong or direction is counterclockwise. So therefore, we should come up with a positive slope. Okay? And otherwise, if we want to compute the kung atong makuha is negative, therefore the negative slope is the clockwise from left tangent. So, unsa man tong left tangent dari? At ang left tangent, it is just the tangent at point A. Again, ang slope ni A is just the slope of the tangent niya. Then, so therefore, negative siya kay since pa clockwise, no, from the left tangent. Okay? So, muna to ang sign convention. Again, how you're going to read this? It is just the slope. How you going to read this one, kani? It's just the slope of B relative to A. Okay, ano na pagbasa? Okay, that is the first moment area. So, it is just the area of the moment diagram. So, later I'll teach you how to draw a moment diagram. Okay? So, next we have the second moment area. If we want to determine the deviation, we will see deviation that is from the tangent to the point. No? It's the deviation or the vertical distance. Okay, that's the deviation. It is just the second moment area. When we have second moment area, i-multiply natin itong moment diagram by the centroid. Okay? So, how are you going to read this one? Pagbasa na, that is the deviation of B. Just the deviation of B relative to tangent A. Okay? Ingana na pagbasa. Okay? Then, asa dapit ng the deviation of B relative to tangent A kani siya, that T, this one, sorry, pasensya na, I don't know what happened to my, so kani siya, that is the deviation of B relative to A. Okay? So, that is the vertical height from the tangent A, kanitong tangent A, no? Kanitong tangent A, tangent siya kang point A to the B. Okay? Now, kaning isa, this one, kani siya, that is the deviation of A, from the tangent B. So, sa una pag-compute, again, pag-compute ana, it is just the area of the moment diagram times the centroid. So, the moment diagram, if you want to compute the deviation of B from tangent A or relative to tangent A, that is just the area of moment diagram from point A to point B. Okay? Ano na siya? Now, what is our sign convention? So, positive deviation siya if ang atoang B, this one, if our point B is located above the reference tangent. Negative siya if our point B is below the reference tangent. Like for example, this one. Okay, negative kasi since below siya sa tuang tangent A. Positive ni isa kay since below siya from the, or I mean above siya from our tangent or reference line na tangent A. Okay? Now, how are you going to draw or to create a moment diagram? Okay? So, natin method na ginahimo, we have bending moment by parts. In bending moment by parts, okay, other name ani is cantilevering. Okay, so maghimo ta og cantilever at any point sa tuang beam. Like for example, in this beam, kani siya nga beam, kasi ang himo nag-cantilever siya, di ba? Okay, so yun, nag-cantilever siya. Look at point C. Now, when we say by parts, pag may tag by parts, ato ang kwaon ang moment for each load. himuan nato og moment diagram in every load. Like for example, in this one, 200, if this our cantilever, mura ka to siyang gi-separate. Okay? Like for example, okay, so ato siyang i-separate. So if 200 Newton, kadali lang ha. So 200 Newton, how to make a moment? Okay. So, for example, in this case, 200 Newton. Ato siyang i-separate if this our cantilever beam kani. So naatay 200 Newton nga reaction at this point. So, kung atong i-draw ang iyahang shear diagram, kung itong shear diagram ni cantilever ni dapita. Okay, that is 200 Newton. Paano no? Okay, this should be what? Our 200 Newton. Now, to draw the moment diagram anang 200 Newton, it is just 200 times 3. Tama ba? 200 times 3. So, 200 times 3 is equal to what? That is 600 Newton meter. Okay? So, this is now our moment diagram of 200 Newton load. So, by parts, when we see by parts, murag atuwa siyang ikuan. Atuwa siyang isa-isahon nato og himo og moment diagram. Next, we have 300 Newton meter. So, how are you going to draw the moment diagram of 300 Newton meter? No? Take note na mao ni ato ang cantilever dere. So, basically, ang moment diagram, di ba? Padulong sa atong cantilever support. It's just 300. It is just 300 times 2. Then, the moment arm, 1. Okay, that is 600. Okay, negative a moment siya kay since naa siya sa baba. Okay, how to check, no? If balance ba ang imuhang moment. So, if imo na siyang i-add, then they should have a 0 moment. Now, again, pwede po ka diba, anak ko ganina, pwede ka mag-cantilever method bisag asa nga point sa tuang support, sa tuang beam. Pwede ka dari sa point B, gihapon. Okay, pwede ka dira mag-cantilever dira. So, isa-isahon nimo. So, how are you going to compute the moment of 200 Newton? If atong cantilever there is B. So, in that case, pwede ta mag 200 times 1. Kani siya, 200 times 1. Okay? Then, 300 Newton, pababa siya. That is 300. Kani siya. That is 300 times 2 times 1, the moment arm. Then, how about 400 Newton? Si 400 Newton na adare 400 moment arm times 2. So, that is 800. So, mao ni ang ato ang. So, if i-add nimo tanan, no? Balance si batong moment at this point. So, we have 200 moment padulong dito. Tapos 200 Newton moment pa rin. So, that is 200 nato. That is 800 minus 600 is equal to what? 200. 200 no, Newton meter. Then, naputi 200 Newton padulong dito. Okay? Anaon lang ang pag-drawing by parts. Again, unsaon tong pag-by parts, it is just mag-moment diagram ta. Atong i-moment diagram, ang mag-set tag cantilever first, then maghimo ka og moment diagram for each load. Isa-isahon nimo og himog moment diagram ang each load. Okay? So, mo ni ang atong gamiton no para makuha tong moment area of moment diagram. Okay, para makuha to tong slope at the same time para makuha na to tong deviation. Okay? However, pag di ba atong ang computation for the deviation, like for example, B to A relative to B, that is just the area. Ano ang other symbol for area? From A to B, then the centroid any centroid from B or relative to B. So atong centroid dire, no, different ba tong centroid? Nag-vary atong centroid, no, depending on the shape of our diagram, moment diagram. The rectangle, atong centroid, that is just the 1/2, tama? But for triangle, diba, it could be 2/3 or 1/3. Kapalo naman mo na. But for parabolic, in this case, where is the centroid? Centroid na to, that is 3/4 B, kung gikan ta dere. Pag dere gikan, that is 1/3 B. Parabolic siya, again, we have second degree. Now, for third degree na curve, so we have 4/5 B if gikan dere. So, dere, padulong, that is, pila ni siya? That is 1/5 B ni siya. Okay? So, ana lang pag-compute sa centroid. Okay, remember the formula or the equation, no? How to compute the centroid. Okay? So, how to draw the deflection? Like, for example, this one. If we have beam simply supported, no? So, if this our point B here, so that, kanisha, unsa ni siya, that is the deviation of B relative to A. Tama? So, kanisha nga distance, sa man siya, that is the deviation of C relative to tangent line A. Okay, remember that. Pag diri na po ka, if nakit tangent line, sa kang C, padulong diri, sorry. Okay, if nakit tangent line, at this point, kanin, sa tawag ani, that is just the deviation of A relative to C. Again, this is what tangent line is C niha, tangent line of C. So therefore, kani siya nga height is the deviation of A relative to C. Okay, how about this one? Kani. That is just the deviation of B relative to C. Okay? So, how to compute for division of... Okay, let's go back. How to compute how to formulate a formula or an equation for division of C relative to A. It is just the area of moment diagram, take note, from A to C times the centroid from point C. Okay? Centroid from point C. Now, how about to compute for the theta A? Our theta A is kani. Theta A is just the, kani siya, division of C relative to A divided by the length. Nga naman, di ba anak ko na, pag very small atong angle, tangent theta is just basically equal to theta in the radian. Okay? Kay gamay man kayo ang ato ang angle aning nga part. So, tangent theta or theta rad is just equal to the opposite over the adjacent, no? Ana lang. So, our theta, since very small ato ang angle, that is just opposite over the adjacent. Basically, that's just equal to tangent theta. Okay? How about division of B from A? It is just the area moment of from A to B. Okay? So, moment from A to B times the centroid of the moment area diagram relative to point B. Okay? So, are you going to compute for our deflection at point B in this one? So, imo lang himuon, kuhaon lang nimo ni nga height, kani nga height, kuhaon nimo ni height, which is our division of B, no, that height. So, how are you going to get that height? Diba naman kay theta A, multiply nimo siya sa distance, sa x, diba, pares itong sa highway na to grid diagram. So, that is now your deviation ni B. So, to compute for deflection ni B, this is equal to, or let's say that is YB na lang niya para consistent ta sa to ang mga symbol. That is deviation of at B minus the deviation of B relative to tangent line A. Okay, so para makuha na to ni dira nga distance. Okay, let's try to solve problem.